The origin and evolution of the surrounding infinity in which we are embedded is one of the ultimate questions addressed by human beings. The state of the matter supposed to be characteristic for the universe evolution at a few microseconds after Big Bang could be obtained in collisions of ultra-relativistic heavy ions at accelerators built in international research centers. The largest center of this kind is CERN at Geneva, where 10 years ago the largest accelerator in the world, the Large Hadron Collider, became operational, delivering heavy ions and protons close to light speed. The properties and dynamics of such tiny exotic objects are studied by all four experiments: ATLAS, ALICE, CMS, and LHCb. Via their collision are produced tiny pieces of matter formed by its basic constituents, quarks and gluons, called partons, at energy densities and temperatures expected to be characteristic for the initial stages of the universe expansion. Such a mini Big Bang decays in thousands of particles, which are detected and identified by the experimental setup. This huge amount of information delivered by different detectors is processed by dedicated acquisition systems and stored on a dedicated storage system at CERN. The calibration and analysis of such an unprecedented amount of information requires distributed computing and storage resources all over the world, called grid. Among the most important components of the ALICE grid is the NIHAM Data Center of Hadron Physics Department. Over the years, proton-proton collisions producing a very high number of particles became one of the hot topics at LHC. Multi-differential analysis based on orders of magnitude larger than statistics is required. This could be achieved using higher beam luminosity and upgrades of the accelerator and experiments. The ALICE time projection chamber was upgraded by replacing multi-wire proportional chambers with ones based on a new technology, gas-electron multipliers. TPC is a large cylinder with an inner hole housing other tracking detectors based on silicon pixels, and along the axis is the beam where the collision of two beams take place and produces the events. The inner radius is 114 centimeters, the outer one 556 centimeters, and the length 510 centimeters. In the middle is a central high-voltage electrode, metallized foil, and on the end, cups on both sides are the 18 readout chambers, ROC, arranged in two rings, outer and inner. In the TPC Upgrade program were involved many institutions and universities all over Europe and the US, as can be seen in this diagram. The finals activities of assembling and testing ROCs being shared among GSI Darmstadt, 50% of OROCs, HPD Bucharest, 50% of OROCs, and Yale, US, 100% of OROCs. Let's follow the chain of the activity starting from receiving the components of the OROCs up to their transportation to CERN to be implemented in the upgraded ALICE TPC. The gem foils produced at CERN and framed in the Institutes of Physics of Bonn and Munich universities and GSI Darmstadt were transported using dedicated transport boxes, completely sealed and rigid enough for safe transportation. After a preliminary cleaning, the gem transport boxes were opened in the clean transit room of the HPD detector laboratory. The envelopes with the framed gem foils were cleaned using nitrogen spray. Then once more in the assembling room, where the level of cleanliness is better than 250 particles per cubic foot. And finally, are stored in a special dry cabinet. Each frame gem foil is taken out from the special envelope and tested in a special box at high voltage, measuring the leakage current with a dedicated multi-channel picometer. Once such a test is successfully done, the frame gem foils are carefully trimmed around the frame and assembled on the corresponding segment of the OROC's pad plane. The foil is covered with a special aluminum plate in order to protect the microparticles expelled during the soldering of the high-voltage wires to be deposited on the foil surface. Once the high-voltage wires are soldered, the sequence of operations is repeated for the next gem foil. After all foils are assembled, the high-voltage wires soldered, and all gem layers have passed the conductivity and capacitance test, the whole structure is closed in a special HPD-designed test box used for in-house test. The closed OROC is transported in the test laboratory, where it's assembled on a special two-dimensional computer-controlled scanning table, cabled and flashed with a special gas mixture until the content of oxygen reaches values lower than 10 to 20 parts per million. Once the working conditions are reached, the HV is applied on different electrodes and the chamber is ready for tests. The tests are done in terms of energy resolution and gain as a function of applied voltage and gain mapping using the FE-X-ray radioactive source and X-ray tubes. Successfully tested OROC is transported back in the clean room. The housing box is exchanged with an aluminum transport box and stored in the clean room. For secured and efficient transport of the OROC to CERN, we decided to use cars and professional drivers of our institute. Upon arrival at CERN, the chambers are unpacked and tested again in terms of capacitance and conductance, required tests after transportation. Using a dedicated mechanical device, the readout chambers were assembled in the time projection chamber. After TP tests on the surface using cosmic and X-rays and laser beams, the TPC was transported and installed in the ALICE experiment.
Being part of the review committee in Romania, in Bucharest, IFIN HH was also clearly, Michael, a prominent institute